Hi everyone, thank you very much for joining our latest episode of our Proctor podcast, which we are recording right here in our very own Proctor pod up at head office in lovely Perthshire in Scotland. I'm sitting with a couple of my colleagues, Pamela Howat and James Brackenreed Johnston. So if I can just ask you guys to introduce yourselves very quickly, that would be fantastic.
Yeah, thanks, Keira. Hi. I'm Pamela Howat. I've been with Proctor's now since late 2001 even, so 22 years now in the technical department, and it's been great. So senior technical advisor, working in and around advising our customers and product development, so a wide varied, no days are the same.
Thanks, Pam.
Hi there, this is James Brackenreed Johnston. I'm the head of Facades for the Keira Proctor group, and I've been with the company just under 5 years.
Thank you, and I'm sorry I didn't introduce myself. For those that don't know me, my name is Keira Proctor and I'm the Managing Director here at the Keira Proctor group. So today we're going to be discussing some of the myths around airtightness, all of our personal opinions of course. So if I can just start with if we just have a general discussion around airtightness and some of the perceptions and things that might not be quite on the ball. How airtight is airtight?
It's a really good question. I think a lot of it depends on what your parameters are for a build. So, you could have the most airtight building ever, but you would have no air changes. You would have real problems with moisture accumulation, mould and everything like that. And you can also get very historic leaky buildings, like traditional buildings, Victorian buildings, massive amount of air changes. But quite often they were, apart from some of the obvious issues with old buildings, you probably had a lot of air changes there for the actual internal living space was quite safe for people, but absolutely no energy efficiency. So a lot of people say, I want something airtight, and they don't appreciate that it's impossible to get it 100% airtight from one product. I think we have this conversation, it's managing expectations a lot with people, because they do assume that one product will do that job for them regardless, and they don't really think of the interfaces. It's always difficult to say, because you can make buildings very airtight, but what you do on paper can be very difficult to correlate on site. And I think that's where it's managing expectations.
I think obviously from a new build perspective, as opposed to a retrofit perspective, you need to look at how that building is functioning and how that building has functioned in the decades, centuries that it's been built for. Mm-hmm. So you need to take into consideration the modifications that have been done to that property. So the volume of electric products in there, the volume of plumbing in there, the amount of people living in there now. And obviously that will increase the moisture content within there, which obviously if you make your property more airtight, you need to deal with that moisture increase as well at the same time, because it will not necessarily be trapped within that building. But because of obviously the more people living in there, you'll have to make sure that you've got the right air exchanges going on within that property.
I think that's a really important part actually, is to consider the way we use our buildings has changed dramatically. Even from sort of like 40, 50 years ago. People are coming in maybe having 2 or 3 showers a day. There's all the wet towels and there's all the moisture from that. People are maybe not putting clothes out to dry because they can't risk the Scottish or the British weather not to soak their washing, so they're drying them inside. People would open the windows every day to air the houses. People are reticent because they don't actually understand that even if they've got a low energy house, that it's still okay to open windows to let fresh air in. So the way we actually live now is so much different to what we did even 40, 50 years ago.
And if you take into consideration from a new build perspective, utilising modern methods of construction, such as SIP systems and off-site construction, you're going to get that airtightness line a lot better sort of instantaneously. But obviously being aware of the fact that the designed airtightness needs to be achieved over or under, to be perfectly honest with you, because ultimately that MVHR system, which obviously isn't always necessary. You can utilise the passive ventilation system instead of solely relying on an MVHR system, is designed for that specific airtightness. So if your building is too airtight, and so say if you design for 3 and you achieve a 1, then you could be potentially affecting the occupants of the property and making them sick because you don't have the CO2 exchanges in the property. So you need to enhance that MVHR system.
Absolutely. I mean, I think it's fair to say that the health of the occupants in terms of the air quality has to be looked at alongside the airtightness and what it needs to achieve. But I mean, if we can go back, why is airtightness important at all?
Basically, energy efficiency. I mean, you could have the leakiest building if you've got, very, open-ended funding for your heating. But I mean, quite frankly, with the way energy costs have increased dramatically over the last few years, people are looking at how can they ensure that the buildings are cheap. But it's not just that, it's all the associated problems with climate change and CO2 emissions. We can't keep pumping heat into buildings and losing it to the environment, because we've got a real problem there with things like the heat island effect, especially in cities, where we're pumping so much heat out, even from air conditioning units, that it actually means that, the sort of ambient temperatures are rising exponentially every year to an unsustainable point, to a point where actually even air conditioning and MVHR units are never going to be able to cope. And we're seeing that, I think, already in places like London. I mean, I know, speaking to you, James, sometimes the temperatures that you're walking about building sites is just ridiculous. We get that. So, by reducing the amount of carbon emission, we're obviously helping the environment, but also we're not pumping out extra hot air into the in outside. But equally, in the summer, we're not bringing unmitigated hot air into the buildings from outside. So if you do have a insulated and airtight envelope, you're controlling that infiltration as well as that exfiltration in the winter. So it all helps to sort of keeping things controlled, making sure you're not using too much energy. But people may have seen in some of our webinars and CPDs that we have a really quite eye-opening slide where we will put in, the difference of changing your airtightness from a relatively acceptable level down to even just an airtightness of 3 or 1, and the amount of insulation that compensates for, which is quite expensive. So, you can actually save quite a lot on your build by just taking into account good levels of airtightness. But it's difficult getting mass acceptance over here because it's just not the way we've done it.
Yeah.
You go into Europe and they don't think twice about it because it's just the way things are done. But they probably have more extremes of weather, so they've got colder winters and hotter summers. So they've just got there a little bit faster compared to us.
I mean, again, from an airtightness perspective, the importance of it is the fact that you are reducing that unplanned air movement through the building envelope. So if you look at properties that exist, you've got a fireplace, you've got a flue system that goes up through that property. And this is how, obviously, a standard procedure for a fire is that you need that flue, you need that draft in order to make sure that the smoke and everything goes up through out the chimney. But people aren't using fireplaces anymore. They're utilising their central heating system, but they're not blocking up their chimneys in order to make sure that that heat won't escape through the property. So it's just about making sure that all areas are covered in making sure that you don't lose any heat loss through convection through the building envelope, but making sure again at the same time that you're keeping internal occupants healthy.
Yeah, there's quite a big piece around the sort of educational part of especially people in existing buildings, because you can do internal upgrades or external upgrades which can help address the thermal performance and the airtightness of your home. But as you pointed out, James, if you have a fireplace there and it's not being blocked up, then there's a key area where you could lose a lot of air leakage.
Yeah.
But even hidden areas, the amount of heat that you can actually lose through a not very well fitting window, or a door that's not been draft proofed properly. And the sort of the common one is, a square pipe for a round, a square hole for a round pipe, where it's not gone in, they've not gone in with the spray adhesive filler or anything like that. Massive amount of heat loss through there. I think a lot of us that live in older buildings know that the minute you open a kitchen cupboard, even, the blast of cold air that comes in sometimes, because it's not insulated or not proofed behind there and just checked, it's subtle little things that you don't actually appreciate where you lose it from.
And on that point, I mean, we seem to be a little bit behind where Europe is, and certainly North America, in terms of the capabilities of the labour force and recognising, their part in workmanship when it comes to airtightness.
Yeah.
How do you think we can address them?
I mean, personally, I think it's quite difficult when they're under so much time pressure to get buildings up quickly. This is why things like off-site manufacturing can be useful to address these things. But, it's that sort of... Clerk Works was a big thing when I was at college, quite a few years ago now. But, they were going out, they were checking these things, they were signing off on them. I just don't think there's the personnel that understand it. I mean, there are some companies are doing great moves towards this. But I think sometimes just the rate of build, how quickly these buildings have to go up, it could be very difficult for these to be tracked. And also, it's not just one person building it. There's so many different trades and subcontractors and personnel that, you could have signed a bit off, and before you know it, the plumbers come in and whacked a great big hole through something and nobody knows it's there, or, oh, wait a minute, we want this. It's also changing things at the last minute doesn't help.
So where do we sit, or where do you guys sit in terms of passive house? So there's an awful, passive house and airtightness often go hand in hand during conversations. I'm not saying that's right or wrong. We know it's a big part of passive house. James, would you have any comments around the whole, the passive house?
Yeah, I mean, from passive house over the last few years, it's become more understood from a specifier's perspective, because I think the initial information, the initial guidance, if you could call it that, was quite frightening for a lot of specifiers, and basically deemed implausible, impossible to achieve, without massively sort of enhancing the contractors on site in regards to what's required from their building techniques in order to make sure that this building that they were designing achieved the regulations that they wanted. But I think there's been some, not laxing of, but there's been some more simpler ways of phrasing things. There's been more architects being trained in the way of passive house, which has enabled more projects to come through. But again, it's like being sort of achieving net zero. It's all in the wording of what you choose to do. So a lot of people now choose to follow the follow the principles. The passive house principles, which is not achieving passive house, but it's following the principles of passive house. So it's getting there and thereabouts. But we're starting to do high-rise projects now which are required to be passive house, so that the interest is there, the want is there, the demand is there for these properties, obviously for a future-proofing perspective, in order to make sure that these guys do it. So it's not just about low-rise now, it's about high-rise resi projects as well.
And I think it's also moving away from just residential, because people would think, oh yeah, it's fine, I can do a passive house. But, there's so many passive house schools being built, especially in Scotland at the moment. And we're talking, and swimming pools. We've got our new sports centre going up in Blairgowrie at the moment, which is a passive house standard building. And then we had St Sidwell's Point, one of our real success stories over the last few years with Airtightness.
Absolutely.
And actually, the round table discussion where we were hearing about the level of engagement that they got and the passport schemes and all this thing, that actually, on smaller scale projects wouldn't be difficult to engage. It's like our toolbox talks, explaining to people how things work. And actually, it goes back to that point that you were saying earlier, Keira, about the, how do you bridge the skill shortage? I think getting those developers and those installers and builders and tradespeople on board, and actually letting them understand why it's important, and then they can take that pride in their work and they can take that forward. And they don't just take it forward to that project, they take it on to other sites, and then other people learn. So it's a ripple effect throughout. And I think that's where Passive House as an institute, we're really have been very good at promoting and marketing themselves and marketing their principles and what it's about. And I think, it's become like a byword. It's almost a bit like Hoover, or Dyson, with that sort of high-end technology. But I think, zero energy, net zero, or a lot more people are coming towards that, which is not a bad thing, really.
Absolutely. I mean, there are quite a lot of misconceptions around passive houses. They have no windows. They have a window, you can't open them. So all these myths that they're extremely expensive, and we experience a lot of questions about that in our departments. And I think the same goes for airtightness. This concern about it being too airtight. Will you be able to breathe? But I think it's all about planning, isn't it? It's about mitigating unplanned air leakage or air penetration coming outside in.
Absolutely. I mean, that's the biggest problem, unplanned air movement. You have no control over that. A window, you can control it. It gets too windy and drafty, too cold, you close it. I mean, that's not to say that putting in things like MVHR systems and heat recovery systems, there is a degree of needing to put in planned maintenance programs and understand how they work. But again, that's then engagement of the developer with the occupants, and obviously that then needs to be fed down the line if ever that building changes hands. It's there's challenges there, but I think producing documents specific to a house, like a car manual, it can be achieved.
So traditionally in Europe, the approach really has been airtightness was approached internally. Yeah. And what we're seeing in certainly North America and here in the UK is this kind of emerging movement towards looking at addressing your airtightness and air leakage externally. I was just wondering if one of you would be able to talk us through that in a little bit more detail.
Yeah, I mean, from an airtightness perspective, obviously the historic reliance is on your VCL or AVCL, depending upon what terminologies you utilise. But if we're talking about airtightness, then it's worth using AVCL. The problem being with that is obviously because of the change in homes with the volume of electrics, the volume of plumbing that penetrate through that internal line, they naturally will penetrate through that vapour control layer, which is situated predominantly behind that plasterboard line, which will be damaged by contractors which don't necessarily know that it's there, and if they do damage it, it's not something that they can repair. Obviously from a low-rise perspective, you will have a smaller team, a more concentrated team, a more focused team on the project at hand. But from a high-rise perspective, you're talking a lot of contractors, a lot of labour in there, doing a job, getting the job done, and whether they do or even can repair that vapour control layer within that system is up to the site manager, as clerk of works are sort of few and far between these days, to make sure that that's done, and it will only rear its head when the airtightness test is carried out. So what we've seen is a viable movement of the airtightness line to the outside of the building envelope, which obviously won't be affected by follow-on trades, which won't be affected by the property owner hanging TVs or pictures or whatever it may be. So the planned works that will go on from an external point of view will be aware of the fact that this airtightness line is there. And so the damage to that line will be minimalised by the fact that, by the nature of the works going on out there.
I think actually as well, for too long, the focus has been on one element providing the airtightness. And I think it's really important that actually every single part and every single component in that building has a part to play in airtightness. So, best in the world, you could wrap the outside of your building in wrap-tight or wrap-tight UV. But how is that window detailed in? That's where the weak point's going to be. The door going in or any sort of pipe penetrations, we're constantly reviewing details for penetrations and how they all fit in. These are all the parts that are going to actually affect the airtightness, not the choice of the membranes. But by using things like wrap-tight and wrap-tight UV and even ProBreathe, taped and sealed on the outside of the building, you've got a robust airtightness line there that is going to allow the building to breathe, and by breathe I mean allow vapour to pass out of the building and not be trapped. By having that externally and enhancing it with well-fitted insulation, because that's important thermally as well as from an air movement point of view, and even coupling it with a vapour control layer where there doesn't have to be as much focus on how well that's installed. I'm not saying you should install it badly, but you don't have to maybe tape it and seal it to the same extent as you would have to if you're relying on that one component. And then it also means that you've got a robust through wall that will still work even if you've got the people coming in and putting on a massive great big television on the wall that they're having to hack through, or they need to run a duct for their new dishwasher or something like that. So you're still not compromising that airtightness of the building because you're not relying on one component or one layer to do it.
So we've obviously discussed airtightness in quite a lot of detail. What about if our listeners want to do some further reading or get some more information? Where we recommend them to have a look for that?
I should say, first and foremost for this, our website actually has got really, really good, webinars and bits and pieces and brochures and things like that. But things like Passive House themselves, they've got some really good articles and explanation of Passive House and low energy. There's companies like Net Zero Scotland, etc., that are all good resources for more information. But publications, probably things like BRE have got a good section on that. Buildings Research Establishment, and the PAS documents, from a number of purposes. They don't just deal with thermal upgrades and things like that. So what's it, 2020? No, 2030. 2035. If I think about numbers, I never get them right.
Good. Well, thank you both very much for joining today and discussing the topic. We appreciate it. Appreciate your time on the Proctor podcast. And to our listeners, we will be having more episodes coming, so I hope you can join again and that you found this an informative discussion.
Thank you very much.
Thank you.
Thank you.